As much as we love aggregation, we hate aggravation, which I guess is why they call it aggravation. But we're going to talk a little bit about both, hopefully a lot more about aggregation in the next couple of videos, and got some great labs for you here working with ether channels. And an ether channel is simply a logical bundling of 2 to 8 parallel links running between a pair of switches. Now we can bundle fast Ethernet links, we can bundle gig Ethernet links, we can bundle 10 gig Ethernet links, and this bundling is called aggregation. And the deal is here we're going to use more of our available bandwidth. We avoid some of that 50-second delay that comes with the MaxAge and forward delay timers in case there's a problem and we need to, we have a channel go down or a port go down. What's not to love? Well, to avoid aggravation, one of the things we're going to see in the next couple of videos is that ports placed inside an ether channel should be running at the same speed and have the same duplex settings. I mention that because when I say this bundling of fast Ethernet, gig Ethernet, and 10 gig Ethernet, it's not like you would bundle them all together in one channel. We're going to be bundling fast Ethernet links in an ether channel in a couple of labs here, and we'll also see that one of the best things about ether channels is that STP considers an ether channel to be a single link, regardless of how many physical links are actually in it. And the reason we love that is that if one or more of the physical links in the ether channel go down, STP will adjust the cost of that ether channel, the port cost, and it'll give it a higher cost due to the lost bandwidth, but the link is still considered up. So we don't have a kickover to bring another port out of blocking and all the way into forwarding and have that delay built in where we don't have any communication between our switches. You will see all of this in action live in just a moment. And here's the lab that we're going to be using to start with. And we've got 4 Ethernet links between switches 2 and 3. We know that by default, only one of those trunks is actually going to be used. Let me give you a quick pop quiz. Out of these 8 ports, how many of those ports will be in blocking and how many will be in forwarding mode once the network converges? Because I've already got that part set up. They are trunking, I promise you. How many of those ports will actually be in blocking mode? Let's go ahead and take a look. First off, we'll look at switch 3. We're just going to stick with good old VLAN 1 here. And switch 3 is not the root for VLAN 1. You can see that it has a root port at fast 21, but 22, 23, and 24 are all blocking. So if we go over to switch 2, all of our ports are in forwarding mode. We expect that they're all designated ports because we're on the route. So out of the 8 ports overall, 5 are in forwarding mode, 3 are in blocking, but that means we can only use one of those 4 paths. Now that drives us crazy, right? Because we're sitting there looking like, oh, we got a lot of traffic going between 2 and 3. I don't want to use just one of these 4 paths. I want to use all of those paths if I can. And we could put all of them inside an ether channel. And what I want to do for a demo here, though, is just put 3 of them in an ether channel. And then we'll start looking at how failures of links impact STP and impact the ether channel. So let's go ahead and bring the live equipment up again. And like I said, I've already got these babies trunking, so I'm going to do the interface range command. Now note that I'm only putting 3 of the channels in the ether channel. 3 of the links, I should say. The command is channel group, and this channel group number you assign is locally significant only. So just to illustrate that, I'm going to put channel group 1 on switch 2, channel group 5 on switch 3, and it's not going to matter. So I'll put 1 here. Then you actually have to enter the word mode, and we have plenty of time coming up working with LACP and PAGP, but in case you're not familiar with those, I just want to mention now they're ether channel negotiation protocols. We're not going to do any negotiation right now, so I'm going to go with on. A lot of admins don't like to use on in production networks. That's just a bit of a real world note. They'd rather use a negotiation protocol. It's more secure, or considered more secure. So let's go ahead with on there, and we get a message creating a port channel and interface port channel 1. More on that in a moment. We're going to go back. I just want to finish. Let's try that again. We'll do interface range fast. I want you to see as many of these commands or messages as we can. There's a creating port channel interface, port channel 5. While we go through some folderol here on the screen, technical term, the port channel is the logical representation of the Ether channel. If we go into the config, we're not going to see anything like interface Ether channel 1. Nothing like that. What we'll see is interface port channel and then whatever channel group we gave it. So we saw the line protocol on port channel 5 come up a little bit off screen there. And everything else looks good. Let's go back to, there we go, line protocol and interface VLAN 1 change state to up. I was waiting for that because that probably went down while the thing with Ether channels is that it can be a little messy to make them, but they're so good when they're done. Because when you've got one switch all configured for the Ether channel and the other side you haven't gotten to yet, you can have some line protocols go up and down, but it's no big deal as long as everything's back up and running when you're done. And let's go back to switch 2 here. I'll show you what I mean. This is where channel group 1 was created, and then we got a message creating a port channel interface, port channel 1. Again, the port channel is the logical representation of the Ether channel. Here's a message about interface port channel change state to up, line protocol change state to up, so we're all good there. And that should do it. So now we seem to have an Ether channel. Let's go ahead and run show spanning VLAN 1 again and see what the impact is. And things have changed. Now instead of 4 separate physical links, we have one physical link representation. That's FAST24, the one we did not put into the channel group. And we have PO5, which sounds funny to say too, but it's port channel 5. Note that that is the root port here on switch 3. It is forwarding, and it has a cost of 9. So it's considered really better than half, a reduction in the cost. So that was definitely going to be considered the root. The cost is always going to be based on the speed of the interface. We know that, and we had a couple of values to memorize in a previous video. But the thing is, with an Ether channel, once we bundle that bandwidth together, STP realizes that and says, hey, wait a minute, we got a nice fast interface here. Here's the cost. I would not worry about memorizing costs of, 3-link Ether channels, 4-link Ether channels, that kind of thing. But do realize, of course, that the cost is going to be lower. Now, if we go over to switch 2, we're going to expect to see pretty much the same thing. And we do. There's our one physical channel we didn't put into the port channel. There's PO1, designated port, of course, because we're on the route. They're both going to be forwarding, and the cost, again, is 9. The reason that I left 24 out of the Ether channel is I want to show you what happens when one channel in the Ether channel, one of the links goes down. Now, we know if we still had the individual interfaces 21, 22, 23, and 24, and the one forwarding on switch 3 went down, we know what would happen then. One of the other 3 ports would start the transition from blocking to forwarding, but we'd have to wait for that. So let's see what happens when that link, one of those links goes down. And to demo that, I will just shut 21 down. And as soon as I do this, I'm going to run show spanning VLAN 1 as quick as I can. That was pretty quick. So quick it was even before the rest of the messages came up. The line protocol and everything you saw there, that was about the physical interface. We got interface fast Ethernet 21 changed to administratively down. We all know what that means, that the port was manually shut down, and then the line protocol followed. Well, check this out. Fast 024 is still in blocking mode. There's no reason for it to start transitioning because as far as STP is concerned, the port channel, the Ethernet itself, never went down. The cost increased a little bit because there's less available overall bandwidth, of course. We took one of the 3 fast Ethernet links out. But that doesn't matter to STP as far as determining whether the port channel is up or not. As far as STP is concerned, nothing ever happened except a little bit of a loss of bandwidth. So the port channel remains the root port. It continues forwarding. The cost went up, but the best part of it is there's no waiting period. There's no transition because as far as STP is concerned, there's no need for a transition. Nothing ever happened to the port channel. That is the basis or basic config of an Ether channel. What we're going to do in the next couple of videos is look at those negotiation protocols. I'll give you some verification commands as well. and a very simple mathematical operation called an XOR that we need to take a look at as well. So I'll see you on the next video, and we'll start looking at those negotiation protocols.